You're here for past paper questions. Well, let's do it.
It's time for Maths with Mr. Thomas.
That's right, we're on chapter 8, but now we have finished learning everything about scientific notation / standard form. We're going to try to answer some past paper questions that came up in the exam. So, let's apply what we know to this 2023 paper 2 question. Oh, Mr. Thomas, if it's paper 2, what does that mean? Remember, paper 2 is a calculator paper, which means you can use your calculator to answer this question. So, the mass of a helium atom is 6.64 times 10 to the power of negative 24 grams. Woo! A flask contains 300 grams of helium. Woo! Calculate the number of helium atoms in this flask. Woo! And give your answer in scientific notation correct to 3SF. What on earth is SF? It's significant figures. It is. So we're giving our answer correct to 3 significant figures. So, first of all, what do? See for any of these questions. Sometimes when it comes to the past paper questions or any questions in the exam, the thing that sometimes throws people is the numbers are in scientific notation. Oh, it's so confusing like that. So sometimes what is easier is to just put in a regular number. Let's just change this to 50. Imagine if the mass of a helium atom is 50 grams. And a flask contains 300 grams of helium. Calculate the number of helium atoms in this flask. So, if each helium atom was 50 grams, and the flask contained 300 grams of helium, how many helium atoms would you need? In other words, is how many 50s are in 300, and to work that out, what would you do?
We would divide it.
Divide what?
Divide the 300 by the 50.
Yeah, perfect. But remember, the number is not 50. It is 6.64 times 10 to the power of negative 24. So what do?
Oh, we just do the same thing, but we don't divide by 50. We divide by 6.64 times 10 to the power of negative 24.
Perfect. Yes, well done, Rachel. That is right. So you would take the 300, the weight of the helium in the flask, and you would divide that by the 6.64 times 10 to the power of negative 24. Remember, just put brackets around that. If you are keying that into your calculator, you want to type in 300 divided by, open bracket, 6.64, and then the times 10 to the power of button, and then put in negative 24. Remember, this is different in all the calculators. Some calculators you might have to put in times 10, and then use that wee hat symbol, and then the power. Some might use the EXP button, as long as you learn how to do it on your calculator. Also, with the negative, some calculators you can use the plus/minus button, other ones you can use the take away button. Just try to get the right answer, and if you do get the right answer, then it works on your calculator. Just remember how you can use it. So, if you type that into your calculator, you end up getting, it should appear like this on your calculator pretty much, 4.51807 and so on, times 10 to the power of 25. Is that then your answer? No, it's not, Mr. Thomas. Why, Brian? Why is that not the answer? Because that's got loads of significant figures. We want 3. So how do we do that, Brian? Well, the first significant figure is the first number that's not a 0, which is a 4. Beside it is the second significant figure, and beside that is the third significant figure, which means the 1 is the third significant figure. So how do we round this number then to 3 significant figures? Now we have identified the 1 is the third significant figure. Good. Because the 1 is in the second decimal place, we just really round that number to 2 decimal places. So because there's an 8 after the 1 will go up to a 2. So you'd have a 4.52. And then you've still got times 10 to the power of 25. And that is how many helium atoms will be in that flask.
Wow, that's loads.
It is. Woo! Let's try another one. Second question from way back in 2019. Once again, this is a paper 2 question, so you can use a calculator to work out your answer. A sesame seed weighs 3.6 times 10 to the power of negative 6 kilograms. The weight of a poppy seed is 8% of the weight of a sesame seed. Calculate the weight of a poppy seed in kilograms.
Huh? What?
If you're unsure about it, just read it back. Read it slowly, read it again. But give your answer in scientific notation. So this time we are told the weight of a sesame seed, and we're told the poppy seed is only 8% of that. So the poppy seed is going to be a lot smaller. It's 8% of this weight. So how do we work out the weight then of the poppy seed if we know this is the weight of the sesame seed?
Well, we would just be working out 8% of that weight, because 8% of that weight is the weight of the poppy seed.
Perfect, yes, you're right. So we just want to work out 8% of the 3.6 times 10 to the power of negative 6 kilograms. And that'll be the weight of the poppy seed. So how do you work out 8% of something?
There's two ways. You could either do 8 divided by 100 times by the 3.6 times 10 to the power of negative 6.
Good, so you could do the 8 divided by 100 and then times by this number that's in scientific notation.
Or, well, you could reverse that as well. You could do the scientific notation number. Divide that by 100 to really get 1% and then times by 8.
Perfect, it doesn't matter which way around you do it. Divide one of the numbers by 100 and then times by the other number. So, I'm taking the scientific notation number, the 3.6 times 10 to the power of negative 6. I'm dividing that by 100 to get 1% and then I'm multiplying that by 8. If you do it the other way around, if you do 8 divided by 100, because that's what 8% means 8 out of 100, and then times by that, you will still get the same answer. Once again, on your calculator, if you do it this way, you will be typing in 3.6, then the times 10 to the power of button, or that wee hat button, or the EXP, whichever way you do it on your calculator, and then the negative 6. As I'm saying here, you might want to use the plus minus button instead of the subtraction button, but see what works in your calculator. Divide by 100 and times by 8. If you key that in, you end up with 0.000000288 kilograms. But we are asked to give our answer in scientific notation / standard form. So, to put this number in scientific notation, how do we go about doing it? Help me out, Eve. Good. You put the decimal after the first number that's not a 0, and the first number that's not a 0 is this 2. So you'd have a 2.88. And then we would have times 10 to the power of, and what you do is you work out how many places you have to move this decimal to get back to where it is. So that'll be 3 places, then 4, then 5, then 6, then 7. So because we're moving the decimal back 7 places in our head, you'd have times 10 to the power of negative 7. So that is the weight of a poppy seed in kilograms.
Oh, that was actually quite easy.
It is. Let's try another one. Example 3 from the 2018 paper 2. And once again, because it's paper 2, it means you can use a calculator to answer this question. Venus and Earth are 2 planets in our solar system.
Mr. Thomas, I live there!
Me too. The volume of Venus is approximately 9.3 times 10 to the power of 11 cubic kilometers. And this is 85% of the volume of the Earth. Calculate the volume of the Earth. How do we go about doing this one? Can anybody help me? Nikki, what do you think? Yeah, good. It's just really a reverse percentage question. If you remember back from chapter 4, lesson 4, when you were looking at reverse percentages, what we are told is that volume, the volume of Venus, is 85% of the volume of the Earth. So we are wanting to get back to that 100%. So, for a reverse percentage question, if you remember, in your head you're starting with 100%. You then add or subtract the percentage change. But here it's not saying that it's decreased by a certain percentage or increased. It's already giving us that current percentage. So this current percentage we are told. So what we would say to begin with is, because we know the current percentage is 85, we would say that 85% would equal, and we know the volume of Venus, it tells us that. So the 85% of the Earth's volume is equal to that 9.3 times 10 to the power of 11. What we want to do is we want to reverse that percentage back to 100%. We want to find out what that is, because that 100% is going to be the volume of the Earth. And to do that, as it says here, we want to go via another percentage. And often that percentage, especially if it's calculator paper, is 1%. So, how do we do this? Sophie, what are you thinking?
Well, to go from 85 to 1, you divide by 85. So you divide the 9.3 times 10 to the power 11 by 85.
You do, perfect, yeah. And if you do that, if you divide both sides by 85, it's So divide 85 by 85 to get 1%. And if you divide this by 85, 9.3 times 10 to the power of 11 divided by 85, 1.094 times 10 to the power of 10. That, therefore, is 1%. How do we then get 100%?
Well, if we know 1%, we times that by 100 to get 100%.
You do indeed, yeah. So we know 1% to get 100%, we just times that by 100. And if you do that, you would have 1.094 times 10 to the power of 12 cubic kilometers. That is the volume of the Earth. I love that. Let's try another one. Example 4. This one is from the 2018 specimen paper 2. Ooh. There are 3 times 10 to the power of 5 platelets per milliliter of blood. On average, a person has 5.5 litres of blood. On average, how many platelets does a person have in their blood? Give your answer in scientific notation. So the first thing is, if we notice with this question, it's talking about millilitres of blood. And it's also talking about litres of blood. So, because we've got millilitres and litres, we want to change it so all the units are the same. So the easiest way to probably do that is to think, well, 5.5 litres, what is that in millilitres?
Oh, there's 1,000 millilitres in a litre, so we times by 1,000.
We do, yes. So if you do 5.5 times 1,000, you get
5,500.
brilliant. Good. So we know that on average a person has 5,500 millilitres of blood. So there are 3 times 10 to the power of 5 platelets per milliliter. So every single one of the milliliters in our body has 3 times 10 to the power of 5 platelets in it. But if we have 5,500 milliliters in our body, how would we work that out? Brilliant. You're right. We would just take the number of platelets in every single milliliter, and because we have 5,500 of them in our bodies, we would times that by the 5,500. Woo! To put that into your calculator, what do?
Yeah, so that's right. 10 times 10 to the power of button, and then 5.
Brilliant, good. You may need brackets around there, you may not, depends on your calculator, but you then times that by the 5,500. And if you type that into your calculator, you end up with 165,000,000 or 1,650,000,000. Is that going to be your answer? No! Why not? Because we're wanting it in scientific notation. So to put the number in scientific notation, put the decimal after the first number that's not a 0. First number that's not a 0 is the 1, so the decimal is going to end up in here. So we're going to have 1 point. And then we've got a 6 and then a 5, and then it's just zeros, so we can forget about them. So it's 1.65 times 10 to the power of. And if the decimal was here after the 1, we would have to move it back 1, 2, 3, 4, 5, 6, 7, 8, 9 places to get to where it is just now. Because you can imagine that as 1,650,000,000.0, if you like. So it means because we had to move it back 9 places, we just put 9. For our index. Woo! Fifth example from 2016. Again, it's a paper 2 question, which means you can use a calculator to solve this. A pollen sample weighs 12 grams and contains 1.5 times 10 to the power of 9 pollen grains. Calculate the weight of 1 pollen grain in grams and give your answer in scientific notation.
Oh, this is difficult. I don't know what to do.
Okay, let's mix this up. Once again, it's sometimes this number here, the 1.5 times 10 to the power of 9 pollen grains. This number, the scientific notation, sometimes throws people. So let's imagine instead it wasn't 1.5 times 10 to the power of 9. Imagine if it was 2. Let's say it's 2 pollen grains. So rereading the question, a pollen sample weighs 12 grams and contains 2 pollen grains. What's the weight of 1 pollen grain? Well, because you know 2 of them weigh 12 grams, how would you get the weight of 1?
You would just divide by 2.
You would, yeah. So you know the weight of 2 of them. So to get the weight of 1 of them, you just divide by 2. So you do the 12 divided by 2. But it's not going to be the 12 divided by 2 because it is not just 2 pollen grains. There are 1.5 times 10 to the power of 9 pollen grains. So we're not dividing by 2. What we're really dividing by is that number that's in scientific notation, the 1.5 times 10 to the power of 9. That will give us the weight of each one. So, to begin with, we're really told that there's 1.5 times 10 to the power of 9 grains, and that's equal to 12 grams. So to get just 1 grain, we're taking that 12 and again dividing it by, remember, I just changed that. I said imagine if it was 2. It's not 2. It's 1.5 times 10 to the power of 9. So we're dividing by the 1.5 times 10 to the power of 9. On the calculator then, that means you would be dividing by 1.5 and then you press times 10 to the power of button and then a 9. And if you work that out, you end up with 0.000000008. That is the weight of 1 grain. But we wouldn't just leave it as that. First of all, we would need our units, and also we have to put it in scientific notation. And to put a number in scientific notation, you put the decimal after the first number that's not a 0, which is that 8. So you can imagine it as 8 point. So that's what we would have. We would have 8 point. And because there's nothing after it, you just put 8.0. But also because it's 8.0, you could just leave that as 8. And then put times 10 to the power of. And imagine if the decimal was there, how many places do you have to move it back to where it is just now? Well, that's moving back 1, 2, 3, 4, 5, 6, 7, 8, 9 places. And because we're moving it back, we would have 8 times 10 to the power of -9. And it would be that many grams. Woo! We've put our units and we've answered in scientific notation. Here's another one from 2015, paper 2. The Earth is approximately a sphere with a radius of 6,400 kilometers. Ooh, that's big. Calculate its volume, giving your answer in scientific notation correct to 2 significant figures. And then part B, the approximate volume of the moon is 2.2 times 10 to the power of 10 cubic kilometers. Calculate how many times the Earth's volume is greater than the moon's volume. So, we're wanting, first of all, for part A to calculate the volume of the Earth. Woo! So, because it says it's approximately a sphere, we're looking at the formula sheet for the volume of a sphere. And the volume of a sphere is 4/3 pi r cubed. It is good. Well done, Colin. It's 4/3 pi r cubed. Which means then, if we start putting in the numbers here, 4/3 is going to say it's 4/3. Pi is going to be the pi button on your calculator. And the radius, what's the radius of the Earth? 6,400. It is the 6,400. And what do we do with the 6,400? Cube it! We do cube it, yes, because it's pi r cubed. So we would cube that radius. If you put that into your calculator, it is a paper 2 question, so you would be given a calculator to help solve that. If you type that in, you end up with 1.098 times 10 to the power of 12. Is that your answer?
No, it's not. We're told to give our answer correct to 2 significant figures. And even if we would still have to put down the units.
Good, but I'm only going to put the units just in the last line. But you're right, you do have to give it to 2 significant figures. So what is that 2 significant figures? Well, the first significant figure, first number that's not a 0, is the 1. The one beside that is always the second significant figure. So this here, this 0, is the second significant figure. Notice it is in the first decimal place. There's the decimal, it's the first number after. So because it's in the first decimal place, we just really round that 1.098 to 1 decimal place. And what is 1.098 to 1 decimal place? 1.1. Good, because the number after is a 9, so that 0 changes up to a 1, so we'd have 1.1 to a couple of significant figures. But make sure you keep that times 10 to the power of 12. And the units this time would be cubic kilometers. It is indeed good. So the volume of the Earth is 1.1 times 10 to the power of 12 cubic kilometers, correct to 2 significant figures. Way. Part B, the approximate volume of the moon is 2.2 times 10 to the power of 10 cubic kilometers. Calculate how many times the Earth volume is greater than the moon's. Let's imagine, let's mix this up, because sometimes, once again, it's these numbers in scientific notation that sometimes mess people up. Let's say the volume of the moon is just 2. Let's say the volume of the Earth is 8 cubic kilometres. We want to know how many times the Earth's volume is greater than the Moon's. How do we do that then? If the volume of the Moon was 2 cubic kilometres, if the volume of the Earth is 8 cubic kilometres, how many more times? In other words, how many 2's are in 8? Which is 4. So how do you get 4 using 8 and 2? You divide. Good, you would do the 8 and then you would divide that by the 2. You would divide it by that number there. So really what you're doing is you're taking the volume of the Earth and then dividing it by the volume of the Moon. But it's not 8 and 2 that we have. It is 1.1 times 10 to the power of 12. That was the volume of the Earth. We use our previous answer, correct to two significant figures, and we divide that by the volume of the Moon, the 2.2 times 10 to the power of 10. Once again, I sometimes just imagine it with more regular numbers rather than these numbers in scientific notation. I find that sometimes makes these questions a little bit easier to work out what you do and then just apply the scientific notation to it. So on a calculator you'd be typing in 1.1 then times 10 to the power of, or the EXP button.
Hello, don't forget about me. Some of you will use me. Haha. Bye. Hello. Bye. Hello. Bye.
And then you would put in a 12 and you're dividing that by,
Hello. Bye.
2.2 times 10 to the power of 10. If you type that into your calculator,
Hello. Bye.
beep, 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 boop, beep, boop, boop, beep, boop, boop, dee, 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 you end up with 50. You got 50? Me too. Well done. Which really means that the Earth's volume is 50 times greater than the Moon's volume. Woo! That's your answer.
Well, that means the Earth is pretty big, man.
It is indeed. It's 50 times bigger than the Moon's volume.
Whoa.
And final example. This is from the 2024 paper 2. Notice all these examples are always paper 2 because the majority of the time you will be using a calculator to solve these problems with scientific notation. So an ant colony occupies an area of 250 hectares. There's an average of 1.22 times 10 to the power of 6 ants per hectare. Calculate the number of ants in the colony and give your answer in scientific notation. Once again, if you sometimes find these questions a wee bit confusing with what you actually do, let's just change that number. Imagine if 1.22 times 10 to the power of 6 was just another number. Imagine if it's 6. Let's say there's an average of 6 ants in each hectare. And an ant colony occupies an area of 250 hectares. Well, if you know there's 6 ants in each hectare and you've got 250 hectares, what would you have to do? Yeah, there's 6 of them in each one. You would times that by 250 because there's 250 hectares. But again, the number that you have is not 6. It's 1.22 times 10 to the power of 6. But it's the same method where we're multiplying 6 by the 250. So instead, we would just multiply the 1.22 times 10 to the power of 6 by the 250. So to work out the number of ants, take the number that you have in every single hectare and multiply it by the number of hectares. So the 1.22 times 10 to the power of 6, if you type that into your calculator, you'll be putting in 1.22 and then the times 10 to the power of button and then 6. Or however you put that into your calculator and then times that by the 250. If you type that in, you end up with 305 million. But we're wanting that in scientific notation. And for scientific notation, remember, put the decimal after the first number that's not a 0. And 305 million, you can imagine the 305 million point 0. So our decimal just now is really there. But if we were moving the decimal to here, we would have 3 point, and then we've got a 0.5. So put in the 0 point, put in the 0.5, and after that it's just zeros, so just ignore them. And then you would have times 10 to the power of, and then think, well, if the decimal was there after the 3, how many places would you have to move it to get back to where it is just now? And the answer would be 1, 2, 3, 4, 5, 6, 7, 8 places. So we'd have a times 10 to the power of 8. And that is how many ants you are going to have. 3.05 times 10 to the power of 8. Whoa, biggest family ever. So, once you feel quite confident with these, Awesome! Well done! You may want to check the review exercise to make sure you've nothing you've forgotten. You may also want to look at some other past paper questions. There'll be more since this video was made up and I haven't put in every single paper. Go back and try some others, just check that you can do them. But if you're looking for an exercise in a textbook, this one in the TJ Maths book is quite good. It's just questions 4, 5 and 8 on page 195. Or the Zeta National 5 Maths books, page 26 has an exercise on standard form. You may want to check that out as well. There's plenty of questions, textbooks, past papers, ask your mum, whatever. Good luck with these. Hopefully it's going well. Not long till the exam. Bye.